Alright, number 5, it says to find the greatest common divisor of 24, 20, 12. Is it possible to find the greatest common divisor of 24 and 20, which is 4? Then find the greatest common divisor of 4 and 12, which is 4. Use this approach and Euclidean algorithm to compute the following. So it says it is possible to find the greatest common divisor of 2 of them. Use that greatest common divisor and compare it with the third number. And we want to use that approach and Euclidean algorithm to compute the following. So we're going to find the greatest common divisor of 85, 55, and 65. Okay, so let's just do the Euclidean with 85 and 55. Those are the first two. So we're going to take the smaller number, 55, and divide it into 85. Alright, it will go into 85 once, leaving us with 30. So we're going to do it again. We're going to do 30 on the outside this time. That's my remainder. The divisor goes inside. 55. 30 goes into 55 once. And that will leave us with 25. Alright, so we're going to do it again with 25 and 30. 25 will go into 30 once. Giving us with a remainder of 5. So we're going to do this again with 5 and 25. 5 goes into 25 5 times, remainder of 0. Okay, so 5 is my greatest common divisor of 55 and 85. Now we're going to do the same method with 5 and 65. So I got this common divisor, seeing if it divides a 65. And 5 will go into 6 once. Bring down the 1 and the 5. 5 goes into 15 3 times. Remainder of 0. Okay, so common divisor between 85, 55, and 65 is going to be 5. It was the greatest common divisor here, and it's the only one here because we get a remainder of 0. Okay, so it's going to be 5 for this first set of numbers. Okay, we're going to do the method again. We're going to use, let's use the smaller number, 4227. Into the largest number, 4119. Okay. So 40 will not go into the first 4 digits, the 42. It will go into the 4019. 10 times will be too big. Let's try 9. And if it's too big, we'll go 8. 9 times 7 is 63. Carry your 6. 9 times 2 is 18. Plus 6 is 24. 9 times 2, 18, 19, 20. And then 9 times 4 is 36, 37, 38. Okay, so it goes in there 9 times. Subtract this off, we get 3 or 6. Got to borrow 1, so 11. Take away 4 is 7. Zeros here. Got to borrow. Comes 10. take away 8 is 2. So we have a remainder of 2076. Alright, so we're going to use this outside, this inside. Alright, so now we're doing 2076 into 4227. Looks like we're going there twice. 2 times 6 is 12. Carry your 1. 2 times 7, 14. 1 is 15. 2 times 0 is 0 plus 1. 2 times 2 is 4. Alright. 7 take away 2. We get 5. Borrow 1, 12. Take away 5. Gives us 7. 1 and 1 is 0. So we end up with 75. Alright, so we're going to do this again. 75 on the outside. And 2076 on the inside. 75 will go into 207 twice, giving us 150. Subtract, that will give us 57, bring down the 6. 75, we're going to 576, 3, 6, 7 times. 7 times 5 is 35. 7 times 7 is 49, plus 3 is 52. Okay. And then subtracting, we have 1, 5, 51 remainder. Okay, so we're going to use 51 to 75 now. 51 goes into 75 once. We get 4, 24. Remainder of 24. So 24 and 51 now. 24 goes into 51 twice, giving us 48. Subtracting, leaving us with 3. Remainder of 3. Alright, and we're going to say 3 and 24 now. 3 and the 24 8 times evenly, remainder 0. So 3 is the common divisor between these numbers. Now, we're going to use 3 with the 4228 and see if it goes in there. 3, and I'm guessing probably not, since it's just one more than the 4227. But let's go ahead and show it. 3 goes into 4228. 3 goes into 4 once. Bring down your 2. 3 goes into 12 4 times. 3 times 4 is 12. So we get 0 here. Bring down the 2. And 3 we're going to 2 0 times. Bring down the 8. 3 goes into 28 9 times. 3 times 9 is 27. Have a remainder of 1. Alright, so we would use 1 and 3. That'll be our last go round. So 1 goes into 3 3 times. So the common least common or greatest common divisor between these two is 1. Greatest common divisor between the other two is 3. So 1 is going to be the answer because 3, they don't have 3 in common.